If you want a job as a software engineer, then you need to know the add two numbers problem. In regular addition, we do that one digit at a time, just like you learned in grade school. Starting with the 1 place, 2 plus 5 is 7. In the tens place, 4 plus 6 is 10, so we carry the 1 over. In the hundredths place, 1 plus 3 plus 4 is 8. But here's the twist. We aren't given regular numbers. We're given numbers like this, as reversed linked lists. You can see these are the same numbers as before, but because we're representing them as linked lists, each digit is now a node that has a value and a pointer to the next node. And because it's reversed, we start in the ones place. So 342 reversed is 2 in the ones place with 4 in the tens place and 3 in the hundredths place. And 465 reversed is 5 in the ones place, 6 in the tens place, and 4 in the hundredths place. So how do we add up two linked lists? Well, because it's given to us reversed, this is really easy. We do it the same way as before. Starting with the ones place, we add up 2 and 5 for 7, add up 4 and 6 for 10, and in the hundredths place, carrying the 1, 1 plus 3 plus 4 is 8. As long as you remember to carry over, this is pretty easy, but this is where people screw it up. People don't carry over correctly into the next digit, and so they don't get the right answer. We'll talk about how to implement this in Python in just a minute, but first we need to talk about the second and third most common reasons why people get this wrong. They don't handle edge cases. For example, what if the lists are uneven? These are almost the same numbers as before, but now the top is 1,342. The first three digits work the same as before, but now we have nothing to add the thousands place to, so if you don't handle this correctly, you'll either leave the thousands place out, or you'll try and add it to a number that doesn't exist and your algorithm will crash. But we handle this exactly the same way we would with a regular number. We just carry it through to the final answer. Not handling asymmetrical lists is the second most common reason why people fail this problem. The third most common reason is carrying over in the last digit. So this is the same numbers as we had before, but now 465 is 665. That means that the first two digits are the same, but when we get to the last one, we end up having to carry over into the thousands place, which doesn't exist. This is very similar to the last problem we had, because really we need to create the thousands place and then carry it through. So if you don't handle this right, you're going to leave it out and miss a digit. So that means we know exactly what we need from this function. We need to add one node at a time, which means we need to be iterating through the linked list, and we can't do that the same as an array. We need to handle asymmetrical lists, and we need to handle the carryover between nodes, including creating a new one if necessary. Now let's do this in Python. First, we'll implement a linked list, which we need to do because there's no built-in linked list data structure in Python. Then we'll use it to implement the solution we just outlined and go through the same example line by line to show how the code works. The linked list is really simple. All you need to do is implement a list node class that takes in the value of the node and has a property to store the next node in, because linked lists are just one node pointing at another node. So if you wanted to create the number 2, you just do it like this. You instantiate a list node with a value of 2, and then if you wanted to turn that into a list with 2 and 4, you do it like this. You instantiate a list node of 4, and then point the node with 2 in it to 4. So now let's use this to implement the function. We need to take in the two lists, and we'll output a list one node at a time. So L1 is the first node in list 1, and L2 is the first node in list 2. The first thing we do when we enter the function is start the linked list that will be our answer by creating a node equal to 0. You're only creating one node in memory, but the variables current and dummy are both assigned to it. We call it dummy because it makes it easier to get the list started and keep track of, but we're actually going to throw this node away later. This will make more sense in a minute. The second thing we do is initialize a variable to keep track of the running tally as we add each digit. We're going to call this carry. Then we loop through the list, and we keep going as long as there's a node from list 1, or a node from list 2, or there's a number being carried over. If there's a node from list 1, we add its value to carry, and then we set L1 to the next node in the list. This is how we iterate through linked lists. We just follow the pointer to the next node. Then we do the same thing for the second list. The node exists, so we add it to carry, and then we assign L2 to the next node in the list. This is where things get interesting. Now that we've added up the ones place into the carry, we create the next node in the answer list to store its value, and reassign current to be at the end of the list. Note that dummy stays the same so we can keep track of the first node in the list. This is also known as the list's head. Then we reset carry by floor dividing it by 10. That means if the value is greater than 10, we'll keep what's left over for the next digit. Now let's do the next iteration. There's a node from the first list, L1, we keep going, and add its value to carry, and increment the L1 to the next node. Then we do the same for L2, adding it to carry and incrementing it to the next node. Then when we add the result to the answer list, notice that we're actually modulating it by 10, so it only passes the first digit of the carry, 0. Then after we increment current to keep track of the last node in the list, we reset carry by floor dividing it by 10, so we keep the first digit for the next iteration. This time L1 exists, so we add it to carry, and we increment L1 to the next node, which in this case doesn't exist. So L1 is now equal to none. Then we do the same for L2, it exists, so we add it to carry and increment it, but next doesn't exist, so its value is now none. Then we create the final node in our answer list, increment current, reset carry, and now when we iterate again, L1 is none, L2 is none, and carry is 0, so we exit the loop and we return the list that dummy is pointing to. This will also work with uneven lists and with carryover into a new node, but I'm going to let you draw it out for yourself to get a better understanding. There's a link to this code in the description. Now let's talk about performance. We always need to know the time complexity or speed and the space complexity or memory. Time complexity tells you how the running time of an algorithm grows as the input size increases. In this case, the time complexity is O max nm, where n and m are the lengths of the two input linked lists. So what does this mean? If you have two linked lists of length 100 and 200, you'll need to go through a maximum of 200 nodes, since 200 is the larger length. If the lists are both 300 nodes long, you'll need to go through 300 nodes, and if one list is 1,000 nodes and the other list is 500 nodes, you'll need to go through 1,000 nodes. So the time it takes to run the algorithm increases linearly with the size of the largest linked list. Space complexity tells you how much extra space you need as the size of the input increases. Now this doesn't count the size of the inputs, just the extra memory we use to solve the problem. In this case, the space complexity is also O max nm. That's because the new linked list we're creating to store the result of the addition is the length of the longest list we're given. So the amount of extra space we need grows linearly with the size of the largest input linked list. In a nutshell, this solution is faster and more efficient than 90+% of answers on Leetcode because it only needs to visit each node once and only needs a small amount of extra space to store. So now you know how to solve the add two numbers problem in Python. What should you do next? The first thing is practice. I've left a link to the code in the description. The second thing is leave a comment below if you have any questions, and I or somebody else will try and help you. And the third thing is, if you haven't already, subscribe to the channel for more coding tutorials like this one. Until next time, this is Canonical Code.